Hi, my name is Aloho and I'm a graduate of MIT. This video is on chemical reactions. The making and breaking of chemical bonds leading to changes in the composition of matter is called chemical reactions. An example is a reaction between hydrogen and oxygen molecules that forms water. You take two hydrogen molecules, react it with one oxygen molecule, and you get two molecules of water. In this reaction, the covalent bonds of hydrogen and oxygen are broken, and the new bonds of water are formed. When we write a chemical reaction, we use an arrow, depicted here, to indicate the conversion of the starting material on the left, called the reactants, to the products on the right. The coefficients 2 and 2, and for oxygen there's a coefficient of 1 that's implied, indicate the number of molecules involved. So for example, the coefficient of 2 in front of the hydrogen molecule means that the reaction starts with 2 molecules of hydrogen. All atoms of the reactants must be counted for in the products because matter is conserved in a chemical reaction. So reactions cannot create or destroy atoms, but can only rearrange or redistribute the electrons among them. So we start out with a total of 2 times 2, 4 hydrogen atoms, and we end with a total of 2 times 2, 4 hydrogen atoms. Same for oxygen, we start with a total of 1 times 2, 2 oxygen atoms, and we end with a total of 2 times 1, 2 oxygen atoms. So no matter is created nor destroyed. All chemical reactions are reversible, with the products of the forward reaction becoming the reactants for the reverse reaction. Using our water equation, 2 hydrogens plus 1 oxygen to get 2 water molecules. Water can also be decomposed to regenerate hydrogen and oxygen, so we actually have one arrow for the forward reaction and a backwards arrow for the reverse reaction because both directions of reaction can occur. Another way to write this is this arrow is 2 hydrogen atoms plus your oxygen atoms, and then an arrow with a double head to produce 2 water molecules. So this 2 opposite-headed arrows indicates that the reaction is reversible. So we can either get the formation of water if we're going in this direction to the right, or the decomposition of water if we're going to the left. One of the factors affecting the rate of the reaction is the concentration of reactants. Let's consider this generic chemical equation, A plus B to get C. The greater the concentration of reactant molecules, that's A or B, the more frequently they can collide with one another and have an opportunity to react and form products, C. The same holds true for products. As the reaction proceeds, meaning that it moves further to the right, the products accumulate. Collisions occur in the reverse reaction, and the reverse reaction becomes more frequent. Eventually, the forward and the reverse reaction occur at the same rate, and the relative concentration of products and reactants stops changing. The point at which the reactants offset one another exactly is called our chemical equilibrium. This is a dynamic equilibrium, meaning reactions are still going on, but there's no net effect on the concentrations of reactants and products. So the net total of concentrations of reactants and products stays the same, although the reactions are still going on back and forth. Equilibrium does not mean that the reactants in products are an equal concentration. It's more like their concentrations are stabilized at a particular ratio.